All right, on to the last section, variation. So up first we have something called direct variation, and so you'll read this as you'll have questions that say something like x varies directly as y or with y, usually as. Um, and if you read something like that, x varies directly as y, that is a equation that looks like this. X, and here's what it means to vary directly. It means equals k times and y. All right, so in other words, there's x. This is varies directly as, and that's y. All right, so we are multiplying, and there's this extra variable that pops out in direct variation. So here's what the steps are. The steps are first, turn the words into an equation. Then what you want to do is substitute given info to find k. Rewrite equation with k, and then use new info to find something else. All right, so we're going to turn words into an equation. We're going to substitute the info to find that magical k, that invisible, or not invisible, but that unknown constant that kind of drives the whole varies directly. We're going to rewrite the equation with what that actual value of k is, and then use this formula again to solve for something else. And this is again used in a lot of physics and a lot of other areas as well. So suppose y varies directly as x. So y varies directly as x, and it says if y is 12 when x is 6, and that's where you stop right there, because you can plug in 12 and you can plug in 6, and now the only unknown will be k. And if I simply divide 6, I get k equals 2. So that's already the first 3 steps. Write the equation that follows the wording, plug in the given info and find k. Now it's time to rewrite the equation with k known. So I know that k is 2 now for this relationship. And now it says find y when x is 9. Well, if I just plug in 9, I would get 18, and I'm done. So it's not too bad, but again, it's a unspoken 3-step process. Set up the equation, solve for k, use k, get new value. All right, and let's go through a few more of those. Got some extra wording here. It says y varies directly as the square of x. All right, and it says if y is 112 when x is 4, let's see here, what is 112 divided by 16? It is 7. All right. Then find y when x is 6. Well, just be careful there that you use your exponents before you multiply. So 7 times 36 is 252. All right. Nigel's paycheck varies directly as the number of hours worked. So this is a real-life application that actually makes a lot of sense. It's kind of obvious. So we're going to say paycheck varies directly as hours worked. And it says for 15 hours of work, the pay is $188.25. Oh, sorry, for 15 hours work. Just thinking about all those 8s. All right, well, if I divide that 15, so 188.25 divided by 15. I get K equals 12.55. So now I know Nigel's hourly rate. So find the pay for 27 hours of work. Well, rewrite the equation. And now substitute 27 hours of work. So hopefully that kind of makes this whole direct variation thing make a little more sense about what that constant does. I mean, that makes sense. Someone's pay is their pay. It just depends on how many hours they work, and depending on how many hours they work will change how much they get paid. But it's this, what I'm going to call, constant multiplying relationship. The pay is the same unless you get a raise. So it's the only thing that's changing is how many hours you work, and so that's where all these extra numbers come in. All right, inverse variation. So if I say, maybe I'll kind of follow some of the wording here. If I say that y varies inversely as x, well, what that means is that y still equals k, but now it's divided by x. So instead of the x multiplying to k, the x is now dividing, all right, the k. And all the other steps remain the same. It's just a matter of doing the word problems. So if temperature is constant, the pressure of a gas varies inversely as the volume. Again, if you've done some physics or elementary physics, you might remember some of these gas laws from high school. I unfortunately still do, but it all comes down to these variation equations. So gas varies, or pressure rather, the pressure of the gas varies inversely as the volume. So there is my equation. If the pressure is 15 with 4 cubic feet, let's see here, now I need to multiply the 4, that makes K 60. So let me update my equation. What is the pressure with 1.5 cubic feet? So now I need to plug in 1.5 for the volume. So 60 divided by 1.5 is 40. All right. I think we just have one more. Joint variation. So joint variation just means that you have more than one direct variation. So let's see what that looks like. So A varies jointly with B and C. So there's an A varies jointly with B and C. And it says A is 72 when B and C are 3 and 8. I'm going to already multiply those and get 24. And that means K should be 3. Let me update my equation now. All right. Find A when B is 4 and C is 2. So B is 4, C is 2. Just multiply all those together. A is 24. And that gets us through all of 7.5. All right. I hope you have a great week. Hope your spring break was great. And remember that our exam is the week next week on the 28th.